Hello. Today's objective is to learn how to translate verbal expressions into algebraic expressions. Verbal expressions. Verbal means words. So we're talking about translating words into algebraic expressions. Well, algebraic is working with variables and numbers, or letters and numbers. And they're both talking about expressions here. There is a difference between an algebraic expression and an algebraic equation. An algebraic equation has an equal sign in it. Expressions do not. So we're talking about translating word problems into algebraic equations or expressions that we can solve or simplify to figure out what's going on with the word problem. This table here, if you are in my class, I will be hopefully making copies for you. If not, you're going to need to make a copy off of this from the video by pausing the video. So I'm not going to stay on this, talk much about this. I'll be moving on. I do want to mention that the red slashes are here for a reason. The word for every is most likely meaning multiply. But occasionally, if you're given extra information, you might have to divide to solve. Per is usually an indication of division. But sometimes with the extra information, you have to multiply to solve. With each, it usually means multiply, but occasionally with extra information, you will need to divide to solve the problem. That often happens between division and multiplication, but those words in particular are ones that I've seen come up a lot, that kids say, well, you said it meant it multiply, you said it meant to... It could mean, you gotta be careful about the extra information being presented. All right. Now that we got those words there, let's look at what operation am I? Well, we're looking at the ratio of 4 and 5. All right, so what operation is that? Here's the key word, ratio. Ratio is a key word for division. So we are dividing. What are we dividing? We're dividing 4 and 5. The first number comes first, then the division, then the second number, 4 divided by 5. Next one says 4 decreased by 9. Decreased by is a key word for subtraction. So we're going to do 4 decreased by 9. 4 minus 9. First minus the second. Here we have 2 more than a number x. More than is a key word for adding. So we're going to do 2 plus a number x. Since it's a variable, we do 2 plus x. Now, here we have 9 less than a number. Notice how I didn't say a number x, number y. It doesn't have to. If it just says less than a number, you get to choose the variable. So let's say z. So we're going to call it z. The other thing here is the less than, which is an indication of subtraction. But there's a very important thing to note here. When you have less than, it's not going to be 9 minus z. It's going to be flip-flopped. It's going to be z minus 9. The second one minus the first one. If you think about this, 9 less than 10 is not 9 minus 10, it's 10 minus 9, because 9 less than 10 is 1. And that would be 10 minus the 9, not 9 minus the 10. The quotient of 5 and y. Well, the quotient, if I spelled it correctly, the quotient is the answer in division. So we are dividing again, and again 5 and y means 5 is the first one, y is the second. 5 divided by y. 3 apples at $4 each. Here we have the key word each, which is the key word for multiplying. We are going to be 3 apples at $4 each would be 3 times 4 which, no, we could get an answer for that, but we're just talking about expressions, so it'd be 3 times 4. Simplified, yes, it would be 12. A couple more here. 5 people per bus. 5 people per bus. The key word here, per. That indicates division. So we're talking about 5 people per 1 bus. There was no 1 there. But when there is just nothing, there's just some word description there and there's no number in front of it, it's understood you have 1 bus. So it's 5 people per 1 bus. So it is an indication of division. However, if later on in the second sentence there, they said there are 6 buses, how many people total, you're actually going to have to multiply by 6 to get your answer. But the per is an indication of division here because it is 5 people per bus. We need to multiply by the number of buses to figure out the number of people. A little trick that you got to watch out for. The total number of people in the class. Total. Total usually is an indication of adding. However, you got to see what other information they give you. If they tell you the total number of people in the class, and before that they said there are 3 people with red shirts, 4 people with yellow, 6 people with green, you'd have to add those numbers up. If they told you you had 4 rows of 6 students each, you could add, 4 plus 4 plus 4 plus, or you do 4 times 6. So total, depending on the information you're given, could mean adding, could be multiplying. Remember, multiplying is just an advanced form of adding. You're just doing a lot of adding at once. Estimate. Some keywords that indicate they're looking for an estimated value is approximately. That's a pretty easy one. You never hear approximately, they're looking for an estimated value. Almost. Estimate your answer. Obviously it says estimate there. Round. Now round, they are looking for an estimate. But you got to be careful. You have to round specifically to what values they tell you. If otherwise, if you just, I'll chop it off here, chop it off there, give it, it's not going to be the right answer. When they ask you to round, they are asking for an estimated value, but they're asking for an estimated value within a certain degree of accuracy there. So you want to be careful. When they say round, yes, it is an estimate they're looking for, but they're looking for a specific estimate. Evaluate for. When you're asked to evaluate an expression for a given value, you're being asked to, what I like to call, plug and chug. You're going to, step 1, rewrite the expression, replacing all the variables with the values given for those variables. Step 2, simplify the expression. In other words, do the math. Follow the order of operations, simplify everything down to a number, if possible. Examples. Evaluate the following expressions for f equals 3 and g equals 5. All right, so first step is to replace the variables with the values. So instead of 4 times f, I'm now going to have 4 times 3 minus 2. Instead of being times g, it's now times 5. Notice how I put the parentheses in there? It helps me remember that I'm going to be multiplying these things. It's not, this does not become 43, it becomes 4 times 3. 4 times 3 is 12. You got to multiply before you subtract, so you got to do this multiplying here, which is 10. So you get minus 10. 12 minus 10 gives you 2. That's the simplified expression for that evaluation. And when you're asked to evaluate, you do need to simplify completely. Here's another one here. We're going to plug in the values. You get 6 times the f value, which is 3, times the g value is 5, over 5 times the f value, which is 3 plus 3. That's the plug part, just like this was the plug part. Now comes the chug, the process of chugging through the problem to find your simplified answer. 3 times 5 is 15. 15 times 6, 16. That's 90. 5 times 3 is 15, plus 3 is 18. Does 18 go into 90? Yes, it does. It goes in 5 times. So our answer is 5. So that would be, this all simplified down to the number 5. You do. You're asked to write an algebraic expression for these first 2 items and then evaluate these 2 for those 2 values of x and y. Pause the video, give it a try. I'll come back with the answers. All right, we're back. 7 decreased by. Decreased by is subtraction. 3 times a number. Times is multiplying. So it's 7 decreased by 3 times is multiplying a number. We don't know what it is, so it's the variable x. Do I have to write that dot there? No. I could just put 3x, and that would be the same thing, because any number next to a letter, you are multiplying. The product of x and 11. Well, again, I'm doing, the product here is telling me multiplication, so I'm multiplying these 2. I could write that as x times 11, but in good form, you put the variable second. So this should be written as 11x, like that. Evaluate. I'm going to plug this in. We have 4 times negative 3 plus 6 minus 4. I've plugged in, replaced the x value and the y value with the values that are given. Parentheses first, according to the order of operations. Negative 6 plus 3 is going to give me, no, sorry, negative 3 plus 6 is 3. 4 times 3 is going to give me 12. 12 minus 4 is equal to 8. There's my final answer on that one. Here, plug it in, we get 6 plus 3 times 4 over 5 times negative 3 minus 3. The fraction bar is a grouping symbol, so we need to work with the top and the bottom before we do the dividing. 3 times 4 is 12, plus 6 gives me 18. 5 times negative 3 gives me negative 15. Negative 15 minus 3, we do the keep it, change it. We get negative 15 plus negative 3, which means we're going to add those 2, and the answer will be negative. You add them, you get negative 18. 18 over 18 is 1, so we get a negative 1 for our answer. So all that simplified down to a negative 1. See you in class.